4600 also requires feedback loops, and the spies are a piece of this. That's how you make measurements for the feedback loop. The idea is, rather than assume perfection, because no matter how hard you try, systems aren't perfect, instead recognize that these imperfections will be there, so you have to manage them and improve them over time to continuously improve the system performance, but also safety. That means feeding back the spy data into the safety case and, over time, converting unknowns into knowns. As an example, you may find out that your system has trouble seeing children next to adults, that it misses them. And what you want is feedback loops so that when this happens and you realize, oh, we didn't see the kid, you fix it so you see the kid next time, and you do that before the kid actually has a chance to run into the street. The feedback loops are pervasive throughout the safety case. Basically, anything that's a value that you think is true that has to be true for safety, you need to be paying attention to, and you need to be feeding back data into the safety case to make sure it really is true. And that includes looking for implementation faults, design faults, gaps in the simulation, gaps in the operational design domain, and gaps in machine learning training data.